Maybe we can start with the demo of the application first, or what do you prefer? Like maybe we can demo first and then we can get back to the VS Code stuff and then look into it, or which one do you prefer?
Yeah, I think I could just do a quick walkthrough of the documentation so you kind of understand what we're actually looking at and how you can apply that to your Gnosis dApp. And then I can show a couple of demos, and then we can actually pull down the code and see what it looks like behind the scenes.
Sounds good. Yeah, that's pretty good. Yeah, feel free to share your screen for the documentation. So there are interesting, by the way, like while Sean is sharing the screen, guys, there have been interesting couple of example in the secret networks documentation also of the couple of direct implementation, pretty good guides on how you can integrate secret network with your dApp. So definitely check that out. And Sean will be meanwhile pulling up the screen. Okay. Yep, it should be visible.
Perfect. But you should see my entire screen, correct?
Yeah.
Let me get rid of these pesky Telegram Slack notifications. All right. So let's start with just a quick overview of the Secret Network docs. So if you just Google Secret Network docs, you'll find it. What we're going to be looking at today is demos that exist right here inside of our Ethereum developer toolkit, our EVM developer toolkit. And what we're specifically looking at is this cross-chain messaging with Secret Path. We're also connected with Axelar GMP. So I don't know if you noticed it's connected with Axelar or not, but if so, you can execute secret contracts using Axelar. But we wanted to build a more customizable solution that was more cost effective and faster than existing bridging solutions that we were seeing out there. And so that's what we did with Secret Path. The way you can essentially think of Secret Path, like, I think we actually have an architecture. So there's a front end where we, using Gnosis, we execute a contract that we've already deployed on Gnosis, and that contract passes encrypted payloads with a relayer to a secret contract that we've already deployed on Secret that then passes your encrypted data into a contract that you've deployed on Secret where you can handle that encrypted data. So I guess more simply put, the way to think about this is the developer flow is you as a developer upload and instantiate one contract on Secret Network, whatever you want that contract to do. It could be like a private voting contract, a field bid auction contract, it could be like a randomness receiver contract. Whatever that contract is, you upload it to Secret. And then using ECDH cryptography, we've already deployed a contract on Gnosis and a contract on Secret, which is called like the private gateway, and the Gnosis contract is the public gateway. That's able to handle that data in transit to pass it to your contract so that it remains encrypted the entire time from Gnosis. Do you have any questions about that before I go further?
Yeah, I think we are so far good. I'm monitoring the chat, so if anything comes up,
Awesome.
I will be definitely putting it up. Yeah.
Perfect. And so using this technology, we've tried to abstract away all the complexities so that all you need to do is just focusing on what you want to focus on as a developer. And we have some demos and use cases here in the docs so that you can pull this down and start building right away. We have like a KB store demo, a sealed bid auction demo, confidential voting, VRF, confidential document sharing, cross-chain NFTs, and cross-chain tokens. This is only for Axelar though, the tokens part. So the rest of these is you can do a secret path. Secret path is just for passing encrypted data. It's not for passing encrypted tokens. So yeah, definitely take a look at this if you're interested in using this technology. We're going to be looking at two of these specifically today. We're going to be looking at the VRF example and the storing encrypted data on secret example. And in this VRF example, what is interesting to note is that we're actually passing an encrypted random number. So it's a random number, but it's also, we're using the encrypted data layer as well at the same time. So I'm just going into this demo right here, the VRF developer tutorial. Let's first just look at a demo. So the way this works, it's called Secret Balls. And what we're doing here is we're requesting a random number from a Secret Network smart contract between 1 and 200. And that number is then passed back to Gnosis, and we then display a random number of secret balls. based on whatever number we requested from the smart contract is returned. And you'll see we're connected with all of these different chains. So like right now I have Gnosis is the network that I've chosen. But we're connected to a ton of different EVM chains. And if you want to just see what that looks like, again, here in the EVM development toolkit, we have our supported networks, EVM, and then we're on mainnet and testnet. So you can see those gateway addresses for all the chains we're connected to. So if we go to Gnosis, here's the gateway address. And the gateway address, that's just the contract I was talking about earlier. It's the public gateway. So that it's the contract that holds your encrypted data and sends it to Secret Network. And so basically, what we're going to learn today is all that you need to do is package your data in a way that that gateway contract can understand, so it can receive it and then send it to Secret Network. So now that I'm connected to Gnosis, what that means is that we're pointing to that Gnosis public gateway contract. So we're actually going to be executing this on Gnosis. So I'm going to request a random number of secret balls. Confirm this transaction. You can see it's a very tiny fee compared to like other VRF solutions like Chainlink. Okay, so it says we've received 117 random secret balls. And right now what that's doing is the transaction hasn't actually gone through. So we have to wait for MetaMask to confirm the transaction. So it's just pulling the most recent random number for whoever last called this contract. But if we say okay, right, we get those balls returned. And we can see that transaction on the Block Explorer on Gnosis. Right, this should look familiar for all of you Gnosis developers. And now if we call it again, we should have a different number than 117 if this transaction went through successfully. So let's see. There we go. So 156 now. Pretty cool, right? And from what we've seen, like it usually takes between 1 to 2 blocks on the EVM for this transaction to be sent from Secret back to Gnosis.
Yep, that's pretty amazing. So here, a very common question I think which comes to my mind is like, if we don't need to wait for the transaction to get confirmed, then shouldn't so if we are just calling the last known random number, shouldn't this be a read call? Like, why are we sending a transaction? Why is it a write call?
This is just to demo that we are actually requesting a brand new random number from the most recent block environment on Secret. So
okay,
yeah, I wouldn't do this in production necessarily. This is just showing that like we just have a struct on the Secret contract that just stores one random number at a time. That's all that's happening. And then when we're executing that Secret contract, it's just pulling a new random number between 1 and 200 and then updating it. And then we're querying that struct to return a random number of balls.
Got it. Okay, yeah, that makes sense.
Yeah, I wanted just to create the most simple sort of example just so that hopefully developers can take that and then use it for their real world use cases.
Yep, yeah.
Cool. Let's see. I think this KV score demo should be working as well. And again, all of this is linked in our doc. So like what we just looked at was there we go. We just looked at the VRF example. Now we're going to look at the key value store developer example. So same thing. I think this should be connected for Gnosis. Just double check. All right. So in this way, all that we're doing is storing an encrypted value in a secret contract, and we're passing it from Gnosis to Secret. So if you wanted to say, so right now we shouldn't be able to query this value because we haven't stored it in the secret contract. Let's try encrypting this. So we're just encrypting our key, our value, and our viewing key are all going to be the same. works. I just pushed updates to this contract, so we'll see. I didn't test this before.
Always interesting to do a live test.
Oh, yeah, if we pull open the transaction, we can just see that like our data is just a random encrypted string or text string. And then only the secret contract can view it with its private key. So let's see. So many tabs. There we go. Okay. Nice.
Nuts. Yeah.
Yep. So you can think of this like the private voting example that we have in our demo and the sealed bid auction. They're basically just exactly this, but just a little more complex on the secret side. It's just all that it really is you're just storing encrypted data and then you're using it in a way that's effective for your data. So this is the most basic example, and then if you go into like the voting example, it just shows it like a little more complexity. But really, it's the same thing. You're passing like encrypted votes to the contract, and you're creating encrypted proposals for people to vote. Any questions about that before we dive into some of the code?
No, so far it's good. So with this application is using the gateway contract, right? Like all the applications, like the first thing which we touch from the Gnosis side of things is the gateway contract, irrespective of what we want to achieve.
Yes, yes. So yeah, and you do that, you interact with the gateway contract on the client side. Like in your front end, that's what we're going to look at right now. I'm going to show like in a React application how we're actually packaging this data for React so that we can send it to that gateway contract. You can also directly call it from Solidity. Like you can, the trick is just figuring out how to format it properly. We have documented this so far only for the client side, for packaging it for the front end, and then also for VRF. We've shown how to do it with Solidity. So like in this tab here, implementing VRF to any EVM contract, we show how to import like the interface for requesting randomness. And it's just like, I think it's like 50 lines of code. You basically just, this is your Solidity smart contract, and then you're able to receive this randomness from secret contract.
Nice.
Yeah.
Cool.
But what I'm going to show us now, let's actually just pull down this repo. Okay.
By the way, folks, for all who is joining right now, like all the demo applications, the doc like are all in the docs. So if you're searching for links, you can just check out docs.scrt.network. You will find all the links, relevant links there.
Yeah, or if you just Google Secret Network Docs, you go to the EVM Developer Toolkit, use cases, you see everything here. What we're looking at right now is VRF, specifically, the VRF developer tutorial. I just pulled down this code here. This is what I just pulled down. So we can actually like open it up in localhost just to see. So I'm just installing the dependencies for React. And there's certain libraries that you need when you're working with this on the front end to be able to properly encrypt everything. But like, so like, that's why I like having these repos already created for you, so you can have all those libraries already installed. The main ones to note is like this Neutrino library and this Cosmos gRPC. And then we use Web3 modal for the actual wallet configuration so that we can configure all of the EVM chains we're connected to. And also the secure random. Yeah, so there's a few libraries you need to be able to work with secret path in the front end. Let's just see if this is working. All right, very cool. So same thing. And so as I said up top, the developer flow for using Secret Path is basically you deploy a contract on Secret Network that you want to do things with, and then you execute that contract from the front end of your application using the Gnosis public gateway contract. So let's just look at that really quick. The simplest way to think about this is just you're able to control Secret Network smart contracts from Gnosis. It's basically like you're like a puppet. you're like you're moving like the Secret Network contract. You're deciding what functions to execute in the contract, and what data to pass. So if we look at this, there's two folders. There's source, which this is all of our React stuff, and there's RNG, which this is actually our Secret Network smart contract. So what we're going to see is that all you have to change, all that you need to do as a developer to execute this secret contract is call the correct function and pass the correct data. So if we look at the Secret Network smart contract, and it might be a little scary if you've never worked with Rust before or Cosmosm, which is the smart contract framework that is for Cosmos developers. Fear not. I'll show you how simple this is. And also ChatGPT is it's a very good helper if you're new to Rust.
For sure.
But all you need to know is that what we're passing from Gnosis is the name of the function we're going to call in the secret contract. So in this instance, it's request random, right? And when I pass this handle, what happens is it calls this try random function. And then in here is where we receive the randomness, a random U8 from the current block. And we store it. We say we want to limit it between 0 and 200. And then we store it in this struct. And then that's what we're actually querying on the front end to display a random number between 1 and 200. But what's being executed by Gnosis is we're just passing the handle that is actually executing the function in the secret contract. So like another way to think of this is like if you instead if this was like a voting contract, this would be like try vote is what you would pass. And you would you would also pass the data you want for your vote, like yes or no. So you pass the name of the handle and you would pass your string of yes or no for the vote. And then you'd have a try vote function. And then in here you would do things with that that vote, that yes or no. You would tally it, and all of that would remain encrypted because it's all happening inside of this TEE, inside of this trusted execution environment.
So in that case, like I don't even need the smart contract like accounts. Like we won't even need that. It's just an
account on Secret.
Yeah, like the account, like the smart contract which we're deploying on Secret, and we're trying to call it from Gnosis Chain. So we don't need the smart contract which we deploy.
So you do. So that's a great question. So if we look at the source file, if we go to our React, and we go into this environment, all that I have here is the contract address and the code hash for my secret contract.
Oh, okay.
So that when I call that method, when I call request random, it's calling it for this contract. So let's actually, and we've written these scripts to try to make uploading and instantiating contracts in the Secret Network as easy as possible. So if I cd into the contract folder, in this node folder, I created a upload script. So if I just install the dependencies, and for this purpose, I just have like a testnet wallet for anyone to use that just comes pre-funded with Secret, so you can just like upload and instantiate your contracts.
Nice.
Yeah, so there's already an upload script written and an instantiate script written. And if you guys start like pulling these repos down and start really customizing them for your use cases and you run into any issues, just like ping me on Discord or Telegram. I'm at Seanrad, SEANRAD, or just like in the developer channel on Secret Networks Discord, and somebody will help you. Because I'm sure like as you start to dive into this more, there will be certain nuances. Like, yeah, we won't worry about that. Let's just If I run node upload right now, what should happen is it should return a contract address and a contract code hash. And on secret, socket hang up.
Maybe
Might be because I'm on Starbucks Wi-Fi.
maybe an RPC issue also, but yeah, that can also be it.
Yeah, there you go.
Okay, nice. By the way, that's pretty clever to just have a wallet funded with the secret network's testnet tokens and like put it in the application directly. This is a great addition of developer experience. They don't need to go and claim tokens. So that's a pretty
Right.
clever one.
Yeah. So all right. So we have a contract address return. Yeah. I mean, so my story is like I started as a developer on EVM. First, everything was like I went to ETH NYC in 2022, and I learned Solidity before that to go hack, and then I did hack FS, and I fell into the EVM ecosystem, and then fell into Cosmos, and learned Rust after the fact. So I have like a pretty strong understanding of like what it feels like to be a Solidity developer coming to Cosmos, and like the discrepancies between what's familiar and what's not. So there's certain things like this where it's like if you've never used Kepler Wallet before, for example, like I don't want that to be a blocker for any developers. I want to try to make that easy for you.
Yep, that's amazing.
All right, so now we have a contract address and a code hash. So like if I wanted to use this new contract, I literally would just take that. I would go into my source folder, and I would just replace that here with that new address and code hash. I'm just going to use the existing one we've been working with. Let's look. So like, I think the best place to go to for this is just in this submit function, because this is where we actually execute the MetaMask transaction. So all of the secret path bridging code, all the encryption logic has all been abstracted away in the secret path folder. There's these 4 different functions. We have construct payload, encrypt payload, generate keys, get public client address. You don't need to change any of this. This is basically all just packaging the data correctly so that it can be formatted to be picked up by the Gnosis contract. Yeah, so there's things like constructing a payload. We encrypt the payload. This is all just like ECDH stuff and secret path stuff. Like, I guess what you would need to change if I'm looking at this right now is if you deployed your dApp to mainnet, then you would want to use the secret mainnet contract. So you would change this from Pulsar 3, which is like the testnet address of secret, to secret 4, which is the mainnet or chain ID. But almost like for testnet purposes, none of this needs to be changed. Let's just look at the submit function. So like I just said, all that we're passing is the handle. So the function that we actually want to call, which in this instance is request random, and the data that we want to pass, which in this instance is the user's wallet address on the EVM. And the reason for that is because in the way I designed this demo example in that contract, if you look at that again, I designed it in such a way that you're receiving the user's wallet and storing that in that struct with a random number. So you're storing the random number along with the user's wallet address. And so that way we just see how to actually pass data if you want. And that data is going to be encrypted and transferred. So if we look back at this, that's why you're passing my address, because it goes into that struct along with the random number. And again, in the way I designed this with Wallet Connect, the chain ID and public client address, this is like the Gnosis Chain address, the contract address you were looking at earlier. I designed it in such a way where like that's also abstracted away. But if you wanted this to be only for Gnosis and for no other EVM chains, you could also do that. But I think what's pretty cool about this, yeah, you could just you could just hard code the chain ID for Gnosis, and you could hard code the this address for the public gateway smart contract. But I do think what's really cool about this is like you can deploy one contract on Secret that taps into like the liquidity and just like the user experience for all the EVM. So like if you want to bring other developers or other users from other networks and have them be able to use more than just Gnosis on your dApp, this is an effective way to be able to do that. But if you want to just have it for Gnosis, you could also do that. Yeah, so I think that's the long and short of it, honestly. That's the function that's actually being called, and all of this is just being passed in a way that the public gateway contract address can actually be picked up.
And all of these are also directly dependent on the smart contract which the developer is building. So based upon the changes we are making on what was that file in which we have the smart contracts? It's
what was the what? The file?
Yeah, so we have in the source folder. So just like that, like based upon that, like we are creating the scripts to call the relevant function. So you guys can just make the changes according to that, according to the smart contract and the functionality you're trying to achieve. Am I right?
Exactly. Yeah. So like let's just for the sake of learning, so like if you look at the KV store example that we were looking at a little bit earlier, the code is going to look almost identical. So like the secret contract, now instead of just having like request randomness for the handle message, we have store value, retrieve value, change value. And so those are the different functions that you could pass. And then store value, like we saw on the front end, we just have a key, a value, and a viewing key. That's the data that we're passing in this function. You have a value and a viewing key, and a key. And if we look at the front end, it's going to be exactly the same. But instead, the handle is store value, and the data is the key, the value, and the viewing key. And literally all the rest of this remains the same. And you just have to make sure that you point to that correct contract address, right?
Again, the same thing. We are picking it up from the env file. So like pretty much, so the only three to-do list is like deploy a smart contract on the secret network, get that account address, put it in the env file, and then make the changes according to the function calls which you are trying to make in your main.js file. So this is roughly a flow of how developers can. Okay, cool. Yeah, this is pretty straightforward and like, yeah, this is pretty interesting. Cool, nice.
Awesome. Yeah, I mean, it's been pretty cool. We've been in the past like 6 months or so bringing this around to different EVM hackathons, like the ETH Bucharest, ETH Rome we were just at, ETH Dam, and there's been like a lot of these winning projects at the hackathons have been using this technology. The second place winner at ETH Rome for the privacy track used Secret Path. The winning project at ETH Dam used this technology, and the winning project ETH Bucharest used this. So yeah, it's been cool just to see EVM developers starting to like dive into Rust and use this and figure out ways that are like, because ZK can be kind of limiting, you know. This is like a way where you have complete composability with privacy, and you can just use Secret as like an encrypted data layer for your applications.
Yeah, that's pretty cool. Makes sense. And I also saw some documentation on secret computation. So is it a part of it or is it something different?
On what?
Secret computation.
Secret computation.
I think, yeah.
Yeah.
I think confidential computing layer part on that.
Yeah, it's a good question. So it's it's synonymous. So decentralized confidential computation, or like a confidential computation layer. These are just words that we use that all mean the same thing, which is essentially that you can use secret contracts, which all of them are built with privacy by default. They're all privacy preserving, and you can use those contracts as an encryption layer for your EVM application.
Hmm. Nice. Cool.
Yes.
Um,
Awesome. Are there any questions in the chat or anything else?
um, Let me go through the chat once quickly. I believe I have been asking, covering all the questions itself, but yeah, I think we are good so far. Other than that, like you were touching a bit on the hackathons part and what people have been building. What do you think are like some of the things upcoming which you think should be built on Secret and can be built deployed on Gnosis? Like, what do you like to see getting built in the future hackathons, or even the developers who are looking at this workshop and trying to think about what they can build? Any ideas on that?
Yeah. I mean, the sky's the limit. Like, it's been interesting to see how people have used secret contracts. Like, for example, like hackathons aside, if we look at some of like the main dApps that are launching on Secret right now, um, like I would say the three biggest dApps right now in our ecosystem is one is called Shade Protocol, and it's private DeFi. So that's really cool. If anyone wants to check out like what private DeFi on the Secret Network looks like, definitely check that out. It's called Shade Protocol. Because like on EVM, all of your transactions are public. There's like a lot of front running going on and all this sort of stuff. On Secret, you have private DeFi, and it's like I think it's a very cool user experience if you've never seen what that can look like before. Another awesome application we've seen recently that launched is called Satoshi's Palace, and it's on-chain gambling with private data, and yeah, that's been really cool. I think the first thing they've launched on mainnet is like it's called Bull or Bear, and you're able to like uh, bet on whether or not the price of Bitcoin is going to go up or down in the next like from like 5 minute intervals.
Nice.
And they're like adding stuff all the time. So that's kind of like they're adding like slot machines and like, blackjack, and yeah, that's really cool to launch. Another thing we're seeing that's right about to launch in the next like week or two, it's looking like, is called Silent Swap. And this is amazing. This is like an incredible technical feat. I think like, the guy who's developing it is also an engineer from NASA. And
Wow.
he's basically figured out a way to have privacy preserving swaps on Ethereum using secret contracts. So that's like token swaps with privacy, which will be really interesting to see how that all what happens with that. In terms of hackathon projects, we've seen some we saw a really cool private voting, like private quadratic voting application that came out of this. Most recently, there was a project that was interesting. It was almost like a mixer of sorts from EVM using Secret Path, where they the Secret Path gateway contract itself is pretty technically involved. It's very the guy who built it is amazing. But that's all public open source, so you can take it and update it for your own usage, and also run your own relayers and whatever you want to do with that. So we saw a team that did a really technical deep dive of Secret Path in a way I've never seen before, where they were actually changing the source code for their purposes so they could try to design this mixer that's not a mixer.
Yeah.
Yeah.
Yeah, because that is also something which, while I was reading through Secret's documentation, came to my mind that won't that enable create mixtures? So
yeah, I think it's possible, but it's not really what the tech is being used for. We have privacy preserving tokens on Secret, but secret contracts are also audible. So it's not that data can't be traced if the developer designs their contract in such a way where they want the data to be able to be audited should it need to. So yeah.
Makes sense. Amazing. Yeah, I think the examples are pretty good. Again, guys, you can just search for Secret Docs in the Google, and from there you can go through all the examples which Sean showed today, and seems like it's pretty straightforward. And I will definitely be trying my hands onto it also trying to deploy a contract and making some function calls. So it's seems pretty straightforward to me. And let's see like what people come up with. And do you guys have any upcoming hackathons where you will be going? You can like share or Secret Network's going to be part of it.
We're going to DevCon. We just concluded a hackathon on Dora Hacks called Hack Secret 4, and we were just in Rome, deep Rome. But yeah, going to DevCon, and then we'll probably go to ETH Denver in, I think, February or March, whenever it is this year. Yeah, TBD. But I'll make sure to let you know too, so you can let Gnosis developers know.
Sounds good. Yeah. So guys, thanks for attending the workshop. I hope you learned a little bit about Secret Network and also the implementation. Definitely tag Secret and Gnosis and share what you have been building using the two protocols, and look out for Secret and Gnosis and DevCon soon. Once again, thanks Sean for such a great like showcase of the product and also the code. And it's been amazing hosting you.
Thank you so much for having me. Thanks, everybody. And if you have any questions,
Thanks,
just
everyone.
ping me on Discord or Telegram at SeanRad.
Awesome.
All right.
Thanks, everyone.
Thanks, everybody.
See you. Bye.